not me so much. I want to show us this part.
Okay.
So ready? All right, this is going to be over models of the urinary system. I'll probably put this in 2 different videos so that we'll be able to load them easily. The urinary system is made up of 2 kidneys, the ureters, the bladder, and then the tube to the outside is the urethra. Looking at the kidneys on the left, remember this is the mannequin's left. The left kidney is a little bit higher than the right one. The right one comes down a little bit lower because of the presence of the liver in the human. Okay, we have a capsule of connective tissue. The kidneys and the ureters, etc., lie behind the peritoneum. That's what we say, it's retroperitoneal. The parietal peritoneum lines the cavity, it's a serous membrane. Okay, then we have the cortex here, and then the medulla. The medulla has pyramids, pyramid, renal column, pyramid, renal column, pyramid, renal column. Okay, the pyramids are made up of collecting tubules. The tips are called the papilla. These little tiny pink dots that we see here are the papilla of other pyramids coming out, from the other side. Then the ureters, and then the bladder with the urethra. Okay, then we'll go to this bigger model. I've used this with the blood vessels before. We have the adrenal glands on top, 2 kidneys, and then here we see the cortex right here. The cortex is where the glomeruli are found, and then the medulla. The medulla is made up of pyramids. It's a lot of collecting tubules. It's like a cone shape. The tip of the pyramid is the papilla, and so it's a pyramid, renal column, pyramid, renal column, pyramid, etc. Okay, the renal column is where the blood vessels enter and leave. Okay, then the papilla, the pyramid, is going to have the urine dripping into the calyces, the receiving chambers. Minor calyx, plural is calyces, and then major, and then finally to the pelvis, and then the pelvis into the ureters, and the ureters are little tubes that are missing here. Okay, but then it goes to the bladder in this position. This is in a male. The ureters would come into the back, so I'm going to pull this out and show you. The ureters would come to the back in this openings. This is the seminal ducts, and these are the seminal vesicles, and this is the prostate gland. If we open this up, we can see I guess it won't come apart. We'll see the folds of the mucosa, called rugae, and then there's a smooth area between the openings of the ureters. We can see those openings on this side that has a little number 40. The openings are here, and I'll turn this back around. So that's between the 2 openings and the opening to the urethra. That is the smoother area, but that's called the trigone, and it doesn't have the folds like the mucosa doesn't fold as much. Okay, so then this would be the opening to the urethra. That would be the internal urethral orifice. This would be the prostatic urethra. This is the prostate gland in the male. And then it would go through the penis, would be the penile urethra, and open at the outside would be the external urethral orifice. Okay, then, oops, sorry. All right, then on this particular kidney, we have just the large kidney. We have the cortex and the medulla. Cortex is F, medulla is E, and the medulla is made of pyramids, renal column, pyramid, renal column, etc. The receiving chambers are the calyces. This little purplish area here would be the papilla of other pyramids coming from the back side. You have the minor calyx or calyces, major, and then the pelvis, and then out the ureter. The renal artery is red, renal vein is blue. Renal artery is carrying oxygenated blood, but a lot of toxic materials, excess electrolytes, and as it passes through the kidney, these are taken out. So the blood leaving the kidney is deoxygenated, but it's the purest blood in the body, but it has gotten rid of a lot of excess electrolytes and some excess urine. Well, actually, it's not urine, it's urea and uric acid, creatinine, etc. So it's the purest blood. Your blood supply goes through the kidney about over 100 times a day. So at any one time, 20% of your blood is in the kidneys being processed. Then the last model is the nephron, and the nephron, you have over 1 million nephrons in each kidney, and the cortex is this part of the kidney, and then the collecting tubules, etc., are in the medulla. So in this, I'll do the blood vessels. This would represent an interlobar artery, arxiform or arcuate artery, interlobular artery, afferent arteriole, glomerulus, where filtration occurs. Efferent arteriole. Then it breaks down to peritubular capillaries. Down here at the lower part around the loop of Henle, the blood vessel is called the vasa recta, and the flow is much slower. That allows for a multiplier effect to occur here. Then it goes into venules, interlobular vein, arxiform or arcuate vein, interlobar vein, then lobar back into the renal vein out to the outside. Looking at the nephron part, we have the glomerulus, the massive capillaries inside the Bowman's capsule. Together, they're called the renal corpuscles, number 6. The renal corpuscle is also known as the Malpighian corpuscle. The first process of urine formation occurs here from the glomerulus to the Bowman's capsule, is known as filtration. The 3 processes are filtration, reabsorption, and secretion. So from the glomerulus, fluid moves through the Bowman's capsule into the proximal convoluted tubule. It's number 9 here. The descending limb of Henle, the loop of Henle, ascending limb of Henle, distal convoluted tubule, and about 15% of the nephrons actually have the distal tubule coming next to the afferent arteriole, and there's a structure called the juxtaglomerular apparatus, which would release the enzyme renin that would lead to an increase in blood pressure if that's needed in a reaction. Okay, then this goes into the distal convoluted tubule and then into the collecting tubule. In the proximal tubule, you have aldosterone working to reabsorb sodium. Chloride follows it, water follows that in obligatory osmosis. In the distal tubule, aldosterone reabsorbs sodium. Chloride would try to follow. It does, but it's not going to allow water to follow here in these tubules unless you have the hormone ADH present. Also, in the distal tubule, when you have the removal or the movement of sodium out, usually it's hydrogen is being involved in controlling the hydrogen levels. But the 2 hormones, aldosterone has to work in the proximal tubule and the distal tubule. ADH only works in the distal tubule and in collecting tubule. So urine goes from fluid is filtered, and then in the proximal tubule, you have reabsorption materials being brought back in, and then all the way to the distal tubule, you have a process and the collecting tubule called secretion, where materials are taken from the blood, emptied into the lumen, and will continue on out. This would make part of the papilla of the pyramid, and at that point, it's called urine. Okay.